this video we're going to look at an example from the Folens book. It's example 5.8 and it's on page 76 in your book, so the solutions are there as well for you to look at. Very similar to last week's questions, but there's just an extra little bit added on, and that's what we do every week. We add on an extra little bit. So these problems involve using the uvast equations as well. So let's just look at the problem here. We have two particles of masses 4 kg and 3 kg which are linked by a taut inelastic string which passes over fixed smooth pulley. Smooth means there's no friction. The system is released from rest, that should be, from when the 4 kg mass is 2 meters above the table and the 3 kg mass is on the table. So here's a picture here, it kind of explains it better. So we have it set up like this, where the 3 kg mass is touching the floor and the 4 kg mass is 2 meters above the floor, and it's released from rest. So obviously what we're going to assume is happening is because the 4 kg has a greater mass, it's going to go down, and the 3 kg mass is going to go up. Because they're connected by a taut string, the rate at which the 4 kg mass goes down, the rate of acceleration A, will be the same as the rate of acceleration at which the 3 kg mass goes up. So first question is to find the common acceleration, so find A. So as always, we start off with our force diagrams. For the 4 kg mass, we have its weight, which is mass times gravity, 4 times g down, and the force up will be tension. Our F equals ma equation then, well, it's accelerating downwards, so the 4g force is going to be bigger than the t force, so our resultant force will be 4g minus t equals 4 times a, and that's equation 1. For the 3 kg mass, again, its weight is 3g, tension is the force pulling it up, but this time, because it's accelerating upwards, when we do our F4 equals ma, the t force is going to be bigger than the 3g force, so it's t minus 3g is our resultant force, equals 3 times a. So this should be okay because we've done this last week. So there's our two equations, and part 1 and part 2 are to find a and find t. So I'll just write these out again here. We have 4g minus t equals 4a, and then our second equation was t minus 3g equals ta, but I'm going to write that minus 3g plus t equals 3a. We don't need to do anything here, the t's will cancel. We have g equals 7a, so therefore divide both sides by 7. A equals g over 7 meters per second squared. So that's part 1 done. Part 2 was to find the tension in the string. So part 1 done, part 2 is to find the tension. So basically find t. So we pick one of our equations. We could pick equation 2, which is t minus 3g equals 3a. So t will equal 3a plus 3g. Now we know what a is. A is g over 7. So that means t will equal 3 times g over 7 plus 3g. That's 3g over 7 plus 3g. Take out your g. 3 over 7 plus 3. T equals, and for that you should get an answer of, you can actually put in your value of g. G is 9.8, remember. So if you put in your value of g, you'll get an answer of 33.6 newtons. And if I go back up here, if you want, for your acceleration, that's 9.8 divided by 7, so a is 1.4 meters per second squared. So this was all the type of thing that we practiced last week, so I've gone through that fairly quickly, so hopefully you're okay with that. Here's the new bit. Calculate the speed at which the 4 kg mass will hit the table. So let's look at what we know. The 4 kg mass is here. Its initial velocity is 0. There's 2 meters between it and the table, so that means s is 2. And we now know that the rate of acceleration, how much it will accelerate by, a, is 1.4 meters per second. So all we need to do, we have 3 of our variables in the uvast, all we need to do is find the speed at which it hits the table, which will be its final velocity v. So we can write that down here. So u was 0, s, the distance it covered, was 2, a was 1.4, and we're looking for v, and we don't know t. So v squared equals u squared plus 2as would be the best equation to use. That's v squared equals 0 squared plus 2 times 1.4 times 2. That's v squared equals 5.6. So v is the square root of 5.6 meters per second. And that's part 3 done, whatever that works out as in the calculator. So that's the only kind of extra bit really. It's just we're adding on some uvast, but some of them do get a little bit trickier that you need to kind of think about, such as this one, example number 4. How much further will the 3 kg mass rise after the 4 kg mass hits the table? So now let's think about this. The 4 kg mass now has hit the table, and the 3 kg mass is up here. Now when that 4 kg mass hits the table, it has to stop. It's hitting a hard surface, it stops. So although its final velocity was square root of 5.6 meters per second, it's going to hit the table and stop. Because this particle, the 4 kg particle, is going down at an acceleration a, it also means that the 3 kg particle is going up with an acceleration a. And that means at this moment, the 3 kg particle is going to have a velocity of square root of 5.6 as well. So when the 4 kg particle has a velocity of square root of 5.6, the 3 kg particle will have a velocity of square root of 5.6. But where the 4 kg particle has to stop straight away when it hits the table, there's nothing stopping the 3 kg particle from moving up a little bit more. And what will happen is it will keep moving up because this is a piece of string. It's not something hard that's stopping it. And the piece of string will kind of crunch up like that. So the 3 kg mass will be here. Let's say it's right here. And its velocity is square root of 5.6. And it will keep going and going and going. And the only thing that's stopping it from going up is going to be gravity. So eventually gravity is going to stop it, say, up here somewhere, when its velocity is going to be 0 meters per second. So if you look at the forces that are acting on it there, when that string is loose, when it's not taut anymore, the only force acting on it is its weight, which is 3 times gravity. So what will its rate of deceleration be? Well, if we use F equals ma, it's going to be 3g times its mass, which is 3 times a. So therefore, the acceleration is going to be the acceleration due to gravity. Gravity is the only thing that's going to be slowing it down there. So if we were to do our uvast for this, we would have its initial velocity is 5.6, square root of 5.6. Its final velocity is 0. Acceleration due to gravity is g, but it's going to be minus g because it's slowing it down. And what we want to find out is, well, how far does it go before it stops? How much further up will it travel? So we're looking for s. So again, we can use v squared equals u squared plus 2as. We're looking for s, so if we rearrange that, and I'll let you work at this, v squared minus u squared all over 2a. That's 0 squared minus square root of 5.6 squared, and this is the advantage of leaving that as square root of 5.6 because that will just become 5.6. Square root squared is going to be 5.6 all over 2 times g. And when you work that out, you get an answer of 2 over 7 meters. So that last part is really tricky, so take your time and try and get your head around that. Watch that part of the video again if you need to. And don't be afraid to let me know if you have any questions.